Good evening and welcome. Tonight we're going to be going through my astronomy book again and learn about the stars in the night sky for the month of March. So we'll talk about what stars you can see in the northern hemisphere and then the southern hemisphere. We'll go over one of those constellations and then we'll learn a little bit more about the science of stars. This book has this binding here, like a spiral bound, and it makes all kinds of really interesting sounds. So, sounds like that. You'll be hearing a lot of them in this video. There we go. But let's talk about stars you can see if you are in the northern hemisphere. That's what it looks like. This month's skies are alive with creatures, as well as Leo the lion riding high. The giant water snake Hydra sprawls across the heavens. Close to its head lies Cancer the crab. In Greek mythology, the crab was plucky enough to attack the hero Hercules while he was fighting the Hydra. Nearby is the small constellation of Canis Minor, the little dog. Along with Canis Major, it is one of the two dogs said to belong to the hunter Orion. So here's Canis Minor, just two stars, which we can see it's right here on the map. There's Procyon the star. It says Canis Minor has only two main stars, but brilliant Procyon is the 8th brightest star in the sky. It was given the name Procyon, Greek for before the dog, because it rises before the dog star Sirius in Canis Major. Then we have Hydra, which, right here. Big, long Hydra. It says Hydra is the largest constellation. However, all of its stars, except for Alphard, are third magnitude, or fainter, but the books weak a bit. So it can be hard to see unless the sky is very dark. Second magnitude Alphard got its name, meaning solitary one in Arabic, because there are no other stars as bright over a wide expanse of sky. And we have Cancer, the crab, which I always thought looked more like a stingray, but it's a crab. And somewhere up here, let me find Cancer right there. Although Cancer has no bright stars, it has the beehive cluster at its heart, right there. This open star cluster is easy to see with the naked eye. Okay, but calm down. About 3,000 years ago, the sun was in Cancer at midsummer in the northern hemisphere, and the latitude where the sun was overhead on that day is still called the Tropic of Cancer. Isn't that interesting? I always wondered why they were Tropic of Cancer, Tropic of Capricorn. That's why. The book is so squeaky tonight. Let's flip this over and read about the southern hemisphere. Maybe I'll be less squeaky. Here we go. The southern hemisphere stars. Let's see. That's the best sound. Okay. A notorious cheat is in the sky right now. The false cross, made up of 2 stars in Carina and 2 in Vela, which can be seen in the night sky picture shown here. The false cross. It sometimes misleads inexperienced sky watchers who think it is the constellation Crux, the Southern Cross. You can compare them in the night sky this month and learn to tell them apart. The false cross is useful for locating Vela, a constellation that has a number of bright stars and clusters, and nearby Volans, Vela and Volans. Let me look for it. As I said before, in the other months I've never been to the southern hemisphere, so there's Vela right there and Volans right here. And let's see if we can see the false cross. There's Crux, very, very famous constellation. Right here is a false cross. Here we go. Vela and Volans. Vela was once part of the ancient constellation of Argo Navis, which was split up into 3 smaller groups in the 18th century. Representing the sails of the mythical ship the Argo, Vela lies across a rich part of the Milky Way. Volans, the flying fish, has popped out of the water just below the keel of Argo. The name was inspired by sailors who reported seeing flying fish gliding across the South Seas. And there's a little did you know box down here. Did you know? A supernova remnant in Vela was the closest so far discovered. It is about 700 light years away and was found in 1988 through the X-rays it emits. Astronomers think a star imploded there about 700 years ago, but there are no records of anyone seeing it go off. Interesting. Then, the star Gamma in Vela is one of the hottest stars easily visible with the naked eye. Its temperature is about 90,000 degrees Fahrenheit or 50,000 degrees Celsius. This is nearly 10 times hotter than the sun. That's a very hot star. More book sounds. We're going to flip the book back over and read about this month's constellation. Here we go. This month we're going to read about Carina. Or at least I hope that's how you say it. Makes sense to me. Carina. Let the book settle. Okay. The southern constellation Carina represents the keel of a ship from Greek mythology. Named Argo, it was sailed by Jason and his crew of Argonauts on an adventure to capture a trophy called the Golden Fleece. The ancient Greeks created an enormous constellation called Argo Navis, picturing the whole ship. In the 18th century, astronomers subdivided it into parts, and the 3 main ones, the sail, which is Vela, the stern, which is Puppis, and the keel, which is Carina, later became constellations in their own right. Carina contains a star cluster nicknamed the Southern Pleiades, and the second brightest star in the sky, Canopus. It is also home to Eta Carinae, an extraordinary massive star that belongs to a huge glowing nebula. Let's read about the Southern Pleiades. The Pleiades is my favorite star cluster because I believe it's the only star cluster you can see with the naked eye in the northern hemisphere. So here's the Southern Pleiades. This attractive cluster surrounds the star Theta Carinae and has nearly as many bright stars as the Pleiades in Taurus. It is best seen with binoculars, which reveal about 30 stars. The Southern Pleiades is the brightest open cluster in the southern hemisphere. Awesome. And here you can see this big, beautiful cloud, the Eta Carinae Nebula. This is one of the brightest nebulas in the sky. With binoculars, you will see the Eta Carinae Nebula as a misty patch in the Milky Way. Near its center is a variable star called Eta. In the 19th century, it flared up, outshining even Canopus. Then it faded out of view for 100 years. Now it is just visible to the naked eye and slowly brightening. This massive star is blowing off large amounts of gas and is buried inside a nebula called the homunculus. The homunculus nebula. Right there. There's a little fact down here. It says the dust clouds in the foreground hide some of the glowing stars in the Eta Carinae nebula. You can see them back here. And then we have another star cluster, which can be seen in Carina. The star cluster NGC 3532. This star cluster is about 1,300 light years from Earth, and it is one of the finest in the southern sky. Although it does not contain any individual star visible to the naked eye, the area is rich with fainter stars. This results in the cluster appearing about third magnitude, and it is easily spotted with the naked eye. Through a small telescope, however, the whole area is filled with stars, about 150 being easily visible. So let's take a look at the constellation. I'm going to go like this. Here we go. So we have this cool plasticky page. It shows you what the constellation looks like, and then we flip it up. You can see what it really looks like in the sky. Big and beautiful, big cloud. You can see the nebula right there. Turn this back down so we can see. Eta Carinae nebula. There's the southern Pleiades. Let's see. Yeah, look at that cluster. Here we have the bright stars. We have Canopus here, right? Canopus. Canis Major's over here. That's who that is. And all the little bright stars. This very pretty constellation. The best sounds. I love that sound. Okay. There we go. Stop indulging myself. And let's read some star facts. Here we go. Let's see what we'll learn about this month. Hold on. That sounded really nice. Oh yeah. The best. Okay. Measuring stars. So let's learn different ways in which the stars are measured. How do we know how far away and how big stars really are? Brightness on its own does not tell us. A star might be nearby and faint, or more distant and bright. Astronomers use a method known as parallax to measure star distances, and this reveals stars' true brightness. But to learn more about the individual properties of stars, astronomers analyze their light. By looking at spectra, they can build up a picture of what stars of different types look like. Let's start over here and talk about star distances. Although the stars in a constellation appear to belong together in the sky, in reality, they may be at very different distances. The 5 main stars in Cassiopeia are a good example. They look similar, but their distances range from 56 to 615 light years, which is the distance light travels in a year. Let's look at each star in Cassiopeia. Here's an observer on Earth looking up. This really pretty, easy to find constellation. This star is the Beta star. It is 56 light years from Earth and 29 sun power. This star is the Alpha star, 323 light years from Earth, 1000 sun power. This is the Gamma star. It is really far away, 615 light years from Earth, and 3,875 times the power of the sun, which is what sun power means. That's a lot of sun power. This star is about right here. It's the Delta star, 100 light years from Earth, or 65 sun power. And this star is the Epsilon star. It is 480 light years from Earth and it has an 800 sun power. It says, in the sky, Gamma Cassiopeiae looks as bright as Beta, but it's actually over 100 times more powerful. And I think I talked in my first astronomy video in January, or maybe it was the one before that in the introduction. Maybe it was that one, the one in December. When we talk about how stars are named. Just very briefly, every star in a constellation is named according to their brightness. So the alpha being the most, going down the list in the Greek alphabet. So gamma is supposed to be, further down the list than alpha, beta, and delta. But the gamma star is actually the brightest, 100 times more powerful. But they were named so long ago before people knew that it was more powerful, before they had ways of measuring just how powerful the stars were. So let's learn more about that. Finding out more about stars. A star's spectrum has narrow gaps in it called lines caused by atoms and molecules absorbing the light. The pattern of lines we see depends on what chemicals are present in the star's temperature. The lines also reveal whether a star is moving toward or away from us. So in this spectrum, it shows the lines that the star that they're measuring has some different elements in it. It has calcium, hydrogen, and sodium. More hydrogen, because it's a star. The wavelength that this light is measured by goes to Earth in a nice little curvy wave, but not all stars have a nice little curvy wave because this is a stationary star. Let's learn about measuring the Doppler effect. A star's movement toward or away from us has the effect of squeezing or spreading the wavelength of the light it emits. When a star is moving toward Earth, its light waves bunch up to make a shorter wavelength. This causes the star's light to move toward the blue end of the spectrum, a blue shift. When a star is moving away from us, the wavelengths stretch out, shifting its light toward the red end of the spectrum, a red shift. This is known as the Doppler effect, named after the Austrian physicist who first noticed the same effect with sound waves. So this star is moving closer toward Earth, a squeezed wavelength, and the lines start moving this way. And in this star that's moving away from Earth, the wavelengths spread out, the lines start moving this way. So you can tell by the measurement of the light on each spectrum, not just what the stars are made of, but whether it's stationary or if it's moving, and whether it's coming closer, moving farther away, measuring its wavelength also. That's really neat. Let's learn more about motion of stars, the proper motion of stars. During a human lifetime, the star patterns do not seem to change, but stars are traveling through space, so their positions in the sky alter slowly. A star's shift over 1 year is called its proper motion. Barnard's star, shown here, in the constellation of Ophiuchus, has the largest known proper motion. You can see it was here in 1996, it moved to here in 2000, moved to here in 2003. Wonder where it is now. That is a very big shift, isn't it? Here it's talking about Proxima Centauri. The closest star to the Sun is Proxima Centauri, a faint red dwarf companion to the bright star Alpha Centauri. Even though it is close at 4.22 light years, its diameter can only be measured by combining two very large telescopes. Its true size is only 40% larger than the planet Jupiter, and it is 13,000 times fainter than the Sun. Very interesting. I always thought Alpha Centauri was the closest star, but Proxima makes more sense. very close together, actually. But let's read about the true brightness of stars. How bright a star appears, or its apparent magnitude, depends on its distance from Earth. Calculating stars' absolute magnitude, the brightness if stars were all 32.6 light years away, reveals true brightness. Fifth magnitude star 61 Cygni is 11.4 light years away with an absolute magnitude of 7.5. Deneb up here is 3,250 light years away, and first magnitude has an absolute magnitude of negative 8.7. It says talk about Sirius down there about why the magnitude is negative. But isn't that interesting how this star is so much brighter than this star, but it's way farther away? It's because of its magnitude. Let's read this note down here real quick about Sirius. Tilt the book kind of sideways so you can see Sirius right there. It says on the ancient Greek magnitude scale, the brightest stars were first magnitude. However, on the more modern scientific scale, Sirius and a few other stars are brighter than first magnitude and therefore have negative values. So that's why Deneb's absolute magnitude is negative 8.7, because it's negative compared to the ancient Greeks' measuring system. Let's learn about parallaxes. Measuring distance by parallax. Try closing each eye alternately. Things nearer to you seem to move relative to more distant objects. This happens because your line of sight from each eye is slightly different. The effect you notice is called parallax. As the Earth moves around the Sun, our line of sight to the stars changes. Due to parallax, near stars appear to shift relative to ones farther away. The amount of parallax tells astronomers how far away a star is. That's really cool. So I like this diagram here. Here's the Earth going around the Sun. Here's the Earth in July, looking at a star. So it appears here in the night sky. But when the Earth moves to here in January, looking at the same star makes it appear there. So this is the parallax that you can measure. Shift in star's position over 6 months due to parallax enables the distance from the Sun to be calculated. So you measure that to figure out where the star actually is in space. I think that's neat. Let's read about the Hipparchus satellite. The most accurate star parallaxes come from the Hipparchus satellite. I always want to say Hipparchus satellite, which measured the distances of more than 1 million stars between 1989 and 1993. The catalog of positions, brightnesses, proper motions, and distances then took a further 4 years of work to prepare. Observations from space have higher accuracy than those from the ground because there is no atmosphere to distort the starlight. Thank you, satellite. Here's a little chart down here. I won't read it out, it's a lot of numbers. But the stars nearest to the Sun: Proxima Centauri, Alpha Centauri, Barnard Star, Wolf 359, and Lalande 21185. And yeah, you can see in light years, Proxima Centauri is 4.2 light years and Alpha Centauri is 4.3. But the brightest stars in the night sky in order are Sirius, Canopus, Alpha Centauri, Arcturus, and Vega. That's pretty cool. Anyway, that's it for tonight for the astronomy. Let me turn these back. So good. Be sure to go out sometime tonight when the sky is clear. Well, not tonight. Sometime this month at night when the sky is clear. find some of the constellations I mentioned depending on what hemisphere you're in. Oh, we didn't read about John Herschel. Sorry, John. Let's read about John Herschel. Let's see what it says. Son of William Herschel, the astronomer who discovered Uranus, John Herschel, 1792 to 1871, became a leading scientist of Victorian times. He traveled to South Africa to survey the southern skies. Here, Herschel witnessed the 1843 outburst of Eta Carinae and sketched details of the nebula. On his return to England, he devised the system of photography we use today. Sorry, John, that I skipped over you. So, thank you so much for watching. I hope you found this video relaxing and educational.